Find the capacitance of an isolated ball-shaped conductor of radius r1 surrounded by an adjacent concentric layer of dielectric with permittivity epsilon. By permittivity, it means, I think, the relative permittivity. So I will just change it to be K by with and add this term relative permittivity K. That means implied in this book. It is the language. I know that what they mean. It is implied. So it is actually a dielectric constant. So this is the dielectric constant K. So what is the absolute permittivity? Absolute permittivity of the dielectric of this particular dielectric is equal to K times epsilon naught. Okay, so we will assume that it's K times epsilon naught absolute permittivity, and I'll just replace this by a K, and also add the word relative permittivity. And mane, this is the sphere isolated R1, and it is surrounded by a dielectric, concentric layer of dielectric. That means it's like this, concentric layer of dielectric. But do not confuse it with, it's not dielectric and then one more shell. No other shell is there. Okay, no other shell is there. So it's just a dielectric. I mean, there is no conductor surrounding it. So you have to find the capacitance of this. Find the capacitance of this. Now, this this conducting sphere will have a charge, plus charge. We assume a plus charge Q on the conducting sphere. Okay, is charge. This is Q. Achha. Then there is a dielectric. Now you know the dielectric has bound charges, right? No? Dielectric is having bound charges, and these bound charges surround it like this. Negative bound charges, negative bound charges here. So minus QB, and positive bound charges. Achha. See, note that inside dielectric the charges are within the substance. No, for conductor the charges will reside outside the substance. But in dielectric, as these are bound charges, so plus QB. So for isolated conductor, so you need one minus Q, right? You need one minus Q because this is a capacitor. Capacitor means this plus Q should have a minus Q pair. So now where is this minus Q pair? If it is isolated, this minus Q pair is at infinite distance. Infinity. At infinity there is the minus Q pair, and what we have to do here is that the charge is Q. Charge is Q and V is potential of this sphere. V is potential of the sphere, that is potential difference between the sphere and infinity. Okay, so what is the potential of the sphere? You know, potential of the sphere means potential difference between this sphere and infinity. Potential of the sphere, in one way we can do with integration, but here I am doing it by the formula of shells. So for the shell, 1 by 4 pi epsilon naught. So the inner shell has how much charge? Q minus qb by r1, right? Total charge q minus qb. We can consider two shells of radii r1 and r2 respectively. Plus qb, now plus qb will come by r2, because if you take the plus qb shell, so this point, so the point here is inside that shell, is a plus qb shell. The point, I mean the surface of this uh, conductor happens to be a point inside the shell having charge qb and radius r2. So that is the formula, you know kq by radius. Acha. Now from the concept of dielectric, that qb happens to be q times 1 minus 1 by k. If you remember that, it's okay. qb happens to be q1 minus 1 by k. Okay. So now to find capacitance, what you do? Q divided by V. So that is one method to find out capacitance. ঠিক আছে? An alternative method to solve this problem by integration. Say this is the field E. Now this is at a distance R. Okay, field is radially outward at a distance R. If R is say between this R, then what is the field at R? Then field at R is in vacuum it would be this, 4 pi epsilon naught r square. Now it's just 1 by k times. Okay. Now if r is greater than r2, then what is the field? Simply it is q by 4 pi epsilon naught r square. From Gauss's law, from Gauss's law, if there is a field, what is the charge enclosed? Q is the charge enclosed. The total bound charge is 0. Okay. So potential of the inner shell V, that is potential difference between the inner shell and infinity, is integration of this from what? EDR from R1 to R2 plus Q by 4 pi epsilon naught R square dr from R2 till infinity. So you can evaluate V, and then capacitance you can substitute as Q by V.